topic. I think it's wait, we're done with this. We're done with that. Now we just have this left. Yay, Casey, we only have one thing left.
Well, you say that.
Well, yeah, so, see, we've done thermal expansion. We've done the zeroth law, and now we just have to talk about pressure.
Is it one topic example?
No, it's stuff. It's stuff and stuff and stuff in between, but don't tell her. So what is pressure? Yes? What's the unit for force? Per? There we go. And the unit is called Pascal. One thing that always used to confuse me when I was little was force is a vector, yes? Pressure should be a vector too, right? But we're dividing it out by area. So pressure is always a scalar quantity no matter what you do. We also use another unit for pressure, which is called, there we go. And why do we call it the atmosphere? No, because we are, of course, the center of the universe, and it all has to be done by humans, right? And so we decided that 1 atm is going to be the pressure we feel at sea level. It's approximately 1 atm, but 1 atm is at the pressure at sea level. Why sea level? No, because sea level is a standard no matter where you are on the planet. Because, right, water maintains its level no matter what you do. So yes, ignoring the tide, in general, the sea level gets maintained overall. Okay, so that's why we decided to call it. And what happens when we go up? The atmospheric pressure decreases, right? Okay. So 1 atm is 1.01 times 10 to the 5 Pascal. And because Pascals are a very, very small number, usually people use kilopascal or megapascal to represent pressure changes. Another thing that you will see in the book is a picture. It's a picture like this. As long as this is sitting like this in water, what's the pressure on every side? Equal. Okay? As soon as you have a situation like that, what's the pressure like at all of these points? The same, regardless of what is going on, right? At the same level, the pressure will remain exactly the same. Now, going back to this. So how do I define the pressure variation with either depth or with height? So people from Newtonian, we've done this before. Now, do I expect you guys to remember? Probably not. But we're going to do it again. Okay, I'm going to start with my definition of density. So what is density? Mass per unit volume. May I also write this as M over V, which can also be written as dm over dv if I don't want to talk about the entire thing. I only want to talk about the small volume element and the small mass element. May I rewrite this as dm equal rho dv? Okay. Now, is dv length times width times height? If I have a cylinder, may I write this dv as dA times dy if this is my area and this is my height? So then may I write this dm as rho dA dy? Okay, so keep this in mind. Now, if I take this cylinder and put it in water, can I do that? Will the pressure at this point be P? Can I call this P? Will the pressure at this point be P plus delta P? The pressure increases as I go lower into water. So then may I write sigma Fy as pressure that's on the top plate? This is all in water. This is going to go up. This is going to go down. And mg will also point down. And this is down. This is up. Minus F down minus mg. That's from intro. Can I write that? Okay. Can I write this as PA? My definition of pressure was force per unit area. So is force going to be PA? Will the force down be P plus delta PA minus rho dA dyg? Which means I can rewrite this. If it's not going anywhere, what is my sigma F? Somebody said it. Right? There's no acceleration. It's just staying there. So then may I write this as PA minus PA plus delta PA minus rho dA dyg? These two get canceled. I am left with 0 equals delta P A minus rho dA dyg. Now, can I replace this dA with A? Because the area is not changing, right? The cross-sectional area is not changing. So I can rewrite this as 0 equals delta P A minus rho A dyg. Or I can simplify this as dP over dy equals minus rho g. And I've just converted this d, this delta, into d. Oh, except for this minus. That should be a minus, right? That should be a minus, and that should be a minus. My fault. This is called weight density. And I can simplify this equation by using Calc 1 very simply. Can I write this like that? May I integrate? Will I get P2 minus P1 equals minus rho G Y2 minus Y1? Or P2 minus P1 equals minus rho GH? And that is an equation you will see over and over and over again in multiple situations. Another terminology, pressure head. If you take this equation right here and you write P2 minus P1 equals minus rho G delta Y, that delta Y is called the pressure head.
Why would I just call it the high limit?
That delta Y is called the pressure head.
Can you scooch back over?
Yes, hold on. There we go.